Okay guys, this is going to be the video for number 5. So number 5 asks us to make pie charts for the different situations. So let's look at situation number 1. So it says a ball starts off at the top of a ramp. I'm going to circle that because that's significant. And then it rolls to the bottom of the ramp. And then a big thing here, this says ignore friction. So here's what I know. When I say ignore friction, that means there's going to be no thermal energy. Because remember, friction is associated with thermal energy. So when I go and think about what's happening, the ball at the top of the ramp, it's going to have all gravitational potential energy. So what I'm going to do is I'm just going to label this EG. That means that everything there is EG. I'm going to do that instead of shading it in. Now, as it starts to roll, some of that EG is going to change into something else. And we think about that potential energy is gradually changing into kinetic energy. So I've still got mostly potential energy, but it's changing into kinetic energy. And then as it keeps going, we might say that at some point it's going to be half and half. Okay, with some potential, some kinetic. And then eventually it's going to be all kinetic. So it transitions from all gravitational potential to all kinetic. Now down here this says a ball starts off rolling in the parking lot, gradually slows down, okay, and comes to a stop. This time it says don't ignore friction. If it tells me not to ignore friction, that means I probably need to be including some thermal energy, okay? So we think about this ball at the very beginning. It's rolling in a parking lot, so it doesn't have any height. If it has no height, that means that it can't have gravitational potential, so there's no EG here. But it is rolling, so if it's moving, that means it's got kinetic energy. Okay, as it moves along, some of that kinetic energy is going to change into thermal energy because there's friction between the ball and the ground. As it keeps going, we're going to reach a point where, I don't know, maybe it's half and half, kinetic and thermal. And then eventually, when it comes to a stop, remember that this one is when the balls come to a stop, then we're going to call that all thermal energy. All of the kinetic has changed into thermal. All right, that's that one.